Hello, I want to make a few comments about part E from question 8 from the assignment. The last two parts, is E and F, were only required for standard level and higher level students. Part F wasn't hard at all. The only thing you needed to do was to use the formula given on part E to check the results you got in part D. But in part E, here, you actually had to prove that that formula is true. And not for the situation of the problem where you have that A and B are 1,200 meters away, and one angle is 37 degrees and the other one is 41. We have to do it for this situation over here. It says over here, use the given figure to show that this is true. So we want to prove a general fact. We want to prove that in any time that we are in such a situation, the relationship between DH and the two angles is the one given by the formula. There are many ways of doing this, but in general, if what we wish is to prove a formula or an identity, it's a good idea to start with one of the sides, the one that looks more complicated, and try to rewrite it and simplify it until we get the side that looks less complicated. In this case, I'm going to start with the right-hand side. That is the one that has the h and the reciprocal of the tangents subtracted. So I'm going to begin by write what it is tangent of theta, and that's based on the picture we have over here. We are talking about the big triangle. So the triangle with the vertices that I'm marking here. So the tangent is going to be the side opposite to it. So h divided by the side that is adjacent to it. So d plus x. So if that's the value for tangent of theta, then if we want to find the reciprocal, 1 over tangent of theta, we need to flip the numerator and denominator in the fraction. So d plus x divided by h. To find the value of tangent of phi, we have to focus on the small triangle. Here, the side opposite to it is also h, but the adjacent one is x. And again, we would like to find the reciprocal of that, so we need to flip numerator and denominator. So this is x over h. So now, to our expression, we have h, and then we have 1 divided by tangent of theta, but we know that this is d plus x in the numerator over h in the denominator, minus. Now we have 1 over tangent of phi, and we found that this is x over h. So we already have a common denominator inside the bracket. Let's write it, h, and we have d plus x minus x, and of course the x cancel. So we have that h times, over there, times d over h is a simplified version of the right-hand side. But we can go ahead and simplify the h, that is both multiplying and dividing, and we get that d is a result as we wish to show.